Okay, it's been a while. I did this research, started it January the 9th, 2012. That's when I actually got the original line of data. It is now February the 2nd, 11:30 a.m. Eastern Standard Time, and this week I've been busy on line 18. It does go from line 18A to Z, just so you know. It's actually a bigger section than line 17. And this is following the alien message that was posted from 17T4B. And if you haven't watched it, you definitely want to see that video. I do have another one that's going to be coming out soon. I'm going to do it after I finish doing the line 18. But this is the one from line 17. This talks about velocity, field, and momentum. I haven't deciphered everything about the video, but I did find out that it talks about two black holes, and those two black holes, NASA has confirmed that they do exist. And you can look at those videos online. It's the the name of the title of that video is Line 17 T4B Alien Contact UFO Travel NGC 6240 Black Hole Hubble Velocity Wow Seti. Okay? So you want to watch that before you start watching line 18. With line 18, you're going to want to watch lines 18A to Z. It's all connected. And it's about the gas and the formulas required to create this gas for this UFO engine, okay? That's what I'm getting from the data, and I'm trying to figure it out. It's very, very detailed, and it's very complicated. So this is worse than line 17A. Okay, so this is based on the Wow Seti 1977 radio signal. That was an alien signal that was picked up. I took the mathematical equation that I found in it. See this big long number here? Okay, so it's 14 divided by 3 divided by 4 divided by 4 divided by 1 divided by 1 divided by 1 divided by 1 divided by 11 equals 0.017. So if I do 14 divided by 0.017, which is this divided by this, it equals 823.5294. So I Googled that number, and I had a bunch of data come up from NASA. Okay? It's different things that has to do with NASA, with spaceships, and basically what I put in the title is line 18A, high pressure temp, which is temperature. NASA, pneumatic flow control valve, jet propulsion, MEMS, Wow Seti. Those are just some of the things that came up in line 18A. Actually, line 18A came up with about 10 things that were in it, and I divided them up into different, like A to, G or whatever you want to call it. Okay, so I Googled the 823.5294, and I find a list of links below. So I Googled the first link of words because, of course, I don't know what this thing is. It's a pneumatic flow control valve of small film, and then I wrote the word NASA beside it to see what would come up. And this ZMA by pneumatic flow control valve of small film came up from China. This is a brand new invention that's been created. It's model number ZMA-BY-64. It has a pressure environment of 6.4. It can handle high temperatures. This is all the data that came up for it. I'm not going to read it all. It's quite complicated. I did pull some of the data from this data. What I do is I show you the data that I find, and then I pull out what I think you need to look at, okay? So we're going to data to read in bold. So overview is ZMA-BY film small pneumatic flow control valve. The pneumatic membrane actuator springs a small multi-flow valve. The regulation applicable to small flow. It has compact structure, small size, lightweight, convenient installation, and maintenance features. On the valve cover, common type -40, I don't know what that symbol means, +230. Cooling type is +230 and +450. I guess that's maybe the temperatures it goes to, I don't know. Type of valve function is a subtype gas off B or the open air K valve. Again, this is just the data that came up that I found that was interesting. just repeated myself there. Okay. MEMS Technology Group came up from NASA Jet Propulsion Laboratory in California Institute. It says microvalve provides the proportional flow control of liquid, provides precisely controlled small propellant flow form of a liquid. Off CRPTAU film on the oxide film for AU compression, pneumatic applications, IEEE MEMS conference, January. So a lot of the stuff coming up is actually, I went to the one site from NASA and they were just posting it January the 29th, 2012. This is how current this information is that's coming up from the Wow Seti signal. Okay? Propulsion System Propellant Management, HSF, the Shuttle. And that's from the spaceflight.nasa.gov website from 2002. During pre-launch activities, this subsystem is used to control the loading of liquid. Large loads are encountered, such as in the control of liquid propellant flows. The pneumatically actuated valves are divided into two types, those that in each sts-me, a small portion of liquid oxygen is diverted. So this is basically giving us, what I get from these links is basic ideas of what this component would be used for in a spaceship. Okay? Evaluation of proportional flow control valves for potential use. Again, this is a NASA government document from R. Shortwell in the year 2000. So basically they're looking, it's for potential use. It was a potential idea for them, and he wrote a paper about it. It's a PDF file. So flow control of propellant to an electric thruster is an important, proportionally controlled valve to provide, and then upstream pressure bleeds down. I don't know what that means. Do you? Okay, number 4 was a size electric liquid compatible microvalve that came up. And it says how to make a pneumatic piston, that came on from ehow.com. A pneumatic piston or air-powered hydraulic is a cylindrically shaped bore in a piece of metal, plastic, or other airtight medium with a movable whatever. This is NASA. Pascal's principle in hydraulics comes up. Squibs are small explosive devices used to film and television to stimulate a bullet hit. And how to adjust pneumatic flow control valves. Again, you can see why the link came up. We have motion control technology coming up from the nasatech.com website. And it's from Rockwood, Illinois. It's designed to solve pneumatic control problems such as over travel, drifting, bearings, low flow ripple, and simple hydraulic controls with no leak adjustments. Operation and are designed to fit into spaces too small for other valves, with sleeve bearings that run on wet film and are pressure lubricated. And another PDF file that came up was presented at the International Organization on Shape Memory. Then number 11 was a thin film with silicone substrate using MEMS fabrication technology. Pneumatic valves are in limited production, finding applications. So they're finding applications for them in analytical instruments and medical whatever. Mass flow controllers and pressure regulators are at prototype stage. So these are just basically being designed. I'm not sure what the year was that they were working on that. Some of these PDF files, I don't click on them to get into it because it said they could have a virus, so I don't bother with them. So what I'm doing again is I pull the data and I look up the words in the data and see what it has to do with building a spaceship. Some valves must be small and lightweight to make the machine portable. Okay. Then an analysis of a high pressure safety valve that came up. That's from alexandria.2.nl. I'm not going to read that one. Again, that's about NASA's experimental data. They're doing experimental data on the strength in a safety valve. And that's from 2009 by A. Bune. Okay. The next one was a pneumatic handbook that came up. Air bubbles, valves, sensors, control valves. Then there's a miniature flow control valve which comes up, products and suppliers. And then there's air oil systems, a lubrication system with small measured quantities of oil are used. So that's the data that came up there. So what we're going to do is go over to here. I'll do my thoughts and then I'll show you the new stuff that I found today. So this is January 9th, 2012 at 1:14 a.m. Eastern Standard Time when I originally started working on this piece of data. My thoughts about the propulsion system, propellant management, flow control, pneumatic valves, SSME, ZMA by -64. Sorry. I've been saying dash and it's actually /. Sorry. Quote, main propulsion system, propellant management subsystem within the orbiter aft fuselage, liquid hydrogen and liquid oxygen pass through the manifolds, distribution lines, and valves of the propellant management subsystem. During pre-launch activities, this subsystem is used to control the loading of liquid oxygen and liquid hydrogen in the external tank. During SSME thrusting periods, propellants from the external tank flow into the subsystem and to the 3 SSMEs. So there again, there's that valve, what it looks like. This is the new one that's been designed in China. Okay, the subsystem also provides a path that allows gases tapped from the 3 SSMEs to flow back to the external tank through 2 gas umbilicals to maintain pressure in the external tank's liquid oxygen and liquid hydrogen tanks. After MECO, this subsystem controls MPS dumps, vacuum inerting, and MPS repressurization for entry. Again, I found this on the spaceflight.nasa.gov in reference to the shuttle. Orbiter, propellant, that's what it's called. Okay, so we're going to go back over here. Now, all this terminology about all these valves, I decided to look up some pictures for you so we could get an idea of what we're talking about here, okay? So these are diagrams of what the links to the left are talking about. MEMS fabrication processes. That's in D1. So I'm going to put that D1 came up over here, sorry. Just so you know, this is D1's MEMS technology group. So I Googled all these little words in here, okay? Because I want to know what are these things that we're talking about. Because I like to know these things, right? So, MEMS fabrication processes. The fabrication techniques used in MEMS consist of the conventional techniques developed for integrated circuit processing and a variety of techniques developed specifically for MEMS. The 3 essential elements in conventional silicon processing are deposition, lithography, etching as illustrated in figure 3. That's from noel.google.com, MEMS fabrication. So here's a picture of what this looks like. This is a thin film, photoerase substrate, patterning, optical lithography, double-sided lithography, etching, wet isotropic, wet anisotropic plasma re-dry. And this is deposition, epitaxy, oxidation, sputtering, evaporation, CVD, LPCVD, PECVD, spin-on method, sol gel, anodic bonding, and silicon fusing bonding. I didn't Google all the words. I probably should have, but it would make it too long. All right? So figure 3. This is an illustration of the basic process flow in micromachining. Layers are deposited, photoresist is lithographically patterned, and then used as a mask to etch the underlying materials. The process is repeated until completion of the microstructure. This tutorial only discusses the basic toolbox used in MEMS fabrication, which are well-established methods and are usually available at major foundry facilities. Plastic. noel.google.com. Okay. The next thing is called a silicon micromachine pressure sensors. And this is a bulk micromachining. That's what it looks like. So what is MEMS? Briefly, electromechanical systems, that's what MEMS are, is the integration of mechanical elements, sensors, actuators, and electronics on a common silicon substrate through micromachining process, which are discussed mainly in this tutorial. What is micromachining? Micromachining is the setup, design, and fabrication tools that precisely machine and form structures and elements at the microscale. It's the underlying foundation, the toolbox of MEMS fabrication. As it will be more illustrated in the next section, silicon micromachining combines adding layers of material over a silicon wafer with etching selectively removed material. Precise patterns in these layers are in the underlying substrate. See figure 1. To achieve special mechanical, electrical, or optical properties. Again, that's from noel.google.com. And this is what pneumatic valves look like. I googled pneumatic valves NASA to find out what their pneumatic valves look like. Okay. A diagram of a normally closed pneumatic valve with a linear cylinder actuator is shown below. Well, it's actually above, just so you know. It was below on theirs, it's above on mine. Okay. The valve is closed by filling the chamber above the piston with gas. So I guess they fill this with gas, right? And evacuating the chamber below the piston. So this must be the chamber below. I'm guessing. Okay, I don't know. The valve is opened by filling the chamber below with piston and evacuating the chamber above the piston. The spring ensures that when the pressure is lost, the valve will close. The valve shown below is a normally closed valve. So it shows it going up and it shows it going down. Okay. So that was at t.arc.nasa.gov. Tech-valve prognostic system modeling. This is brand new. I found this little baby. This is a PRV95 pressure relief valve for aerospace testing. I guess they're just testing it. Suburb.nasa.gov, SBIR. Okay. Successes. They're testing this valve here. And it says government science applications. Applications within the aerospace industry include, but are not limited to, launch facilities, launch vehicles, and test facilities. So basically this little gadget here would be used in that type of setting. Okay. So January 9th, 2012. I think we did that one already. Yeah. Yeah, I did. Okay, sorry. That's why I get confused. Okay, January 24th, 2012, 11:33 p.m. Eastern Standard Time. My thoughts. It looks like several new inventions concerning safety valves have been developed. The valves that came up in this Google search can be used in a high temperature setting. Next, I looked to see if NASA would use this, and they do. Quote, Propulsion System Propellant Management, HSF, the Shuttle. During pre-launch activities, this subsystem is used to control the loading of liquid. February 2nd, 2012, 9:25 a.m. Eastern Standard Time. My thoughts. It must be important. It must have failed before, and now we're getting data to show us something better. Main propulsion system. So, of course, I looked up failure, right, to see if I'm right. So this is from science.ksc.nasa.gov. Shuttle technology. August 31st, 2000. The main propulsion system assisted by the two solid rocket boosters. The orbiter MPS propellant management subsystem consists of the manifolds. Supply would be used if the pneumatic helium supply regulator failed. I thought that was a failure, but actually it was talking about if something fails on the spaceship, then another thing will kick in and take over. So it's got a safety thing that takes over, right? So, quote, the main propulsion system assisted by the two solid rocket boosters during the initial phases of the ascent trajectory provides the velocity increment from liftoff to a predetermined velocity increment before orbit insertion. So basically I saw the word velocity and I think I'm going to pick it up here because we are talking about the velocity of a spaceship, right? The two SRBs are jettisoned after their fuel has been expended, but the MPS continues to thrust until the predetermined velocity is achieved. So basically it's saying there's different stages for it to use its power. Once it gets to a certain level of height up in the atmosphere, it'll add more power and it'll get rid of some parts that belong to it. They kind of like fall off, I think. At that time, main engine cutoff is initiated. So once it gets to the certain orbit, it'll shut off the main engine and it just like glides right into it like a glider would do with air currents and stuff. The external tank is jettisoned and the orbital maneuvering system is ignited to provide the final velocity increment for orbital insertion. The magnitude of the velocity increment supplied by the OMS depends on payload weight, mission trajectory, and system limitations. Coincident with the start of the OMS thrusting maneuver, which settles the MPS propellants, the remaining liquid oxygen propellant in the orbiter feeds system and space shuttle main engines is dumped through the nozzles of the three sts-mps. So liquid oxygen, they dump the liquid oxygen. At the same time, the remaining liquid hydrogen propellant in the orbiter feed system and sts-mps is dumped overboard through the hydrogen fill and drain valves for 6 seconds. Well, that's a bit of a waste, eh? They actually dump stuff. Wouldn't it be nice if they didn't have to dump anything when they went up there? And they just kept everything that they needed? Then the hydrogen inboard fill and drain valve is closed, and the hydrogen recirculation valve is opened, continuing the dump. The hydrogen flows through the engine hydrogen bleed valves to the orbiter hydrogen MPS line between the inboard and outboard hydrogen fill and drain valves. And the remaining hydrogen is dumped through the outboard fill and drain valve for approximately 120 seconds. I guess I should have Googled that to see what it looks like, but you can get a basic idea, right? Again, that's from the science.ksc.nasa.gov site. So we're going to look at some more data here. It says Apollo Command Service Module from Wiki. It came up the propulsion system reaction control when NASA awarded the initial Apollo contract to North American Aviation on the obstacles encountered in some subsystems such as environmental control. Also, the Block 1 service module propellant tanks were slightly larger than in Block 2. So, I get the words Apollo Command Service Module. So I search in the wiki file and I look for the Apollo command for the word fail, because I want to know if anything had failed from the Apollo things. And they did. We had a couple, actually, some real bad ones too. Apollo 13, this is a quote, Apollo 13 had drawn heavily on its entry batteries in the first hours after the explosion. That's pretty nasty, when you have an explosion and you're up in the middle of space. That'd be very scary. And while this new battery could not power the CM for more than 5 to 10 hours, it would buy time in the event of a temporary loss of all 3 fuel cells. Such an event occurred when Apollo 12 was struck twice by lightning shortly after launch. So it looks like they had trouble with Apollo 12 and Apollo 13 from different elements and stuff, right? So this is on Wiki under Apollo Command Service Module. So I got this graph here, and it's a deep space antenna. It says service propulsion engine nozzle, service propulsion system tank. So this is showing the different propulsion systems that you find in the command module. And so this is a command module. This is the top part where the guys sit. I guess they got the docking, their parachutes, the side hatch, compartment tanks, reaction control. You can see it's not very big. It's quite cramped. And then the helium tanks are here, reaction control system, service propulsion tanks. That's all the stuff there. This is the aft boost, forward boost protective cover, launch escape tower, environmental control system, VHF skimmer antenna, your oxygen, fuel cells are there, reaction control, electrical power systems, crew compartment, again, is up here, launch escape motor, tower jettison motor, pitch control. Anyways, that's what you get. So this is what we're kind of talking about, the propulsion things that you find, the valves that they would use in those different components, okay? So, quote, the Apollo 1 flight was canceled by a cabin fire, which killed the crew and destroyed the command module during a launch rehearsal test. So they hadn't even launched it. It was just a rehearsal, and it killed the whole crew. I mean, that must have been terrible. That's their very first flight. I mean, can you imagine how discouraging that must have been for them? So corrections of the problems which caused the fire were applied to the Block 2 spacecraft. So that's where it talked about they made a Block 1 and Block 2. They knew that it might fail, so then they had a Block 2 set up just in case, which was used for all manned missions. So Block 1 didn't work, but Block 2 did. Okay? So February the 2nd, 2012 at 10:15 a.m. Eastern Standard Time. Keywords from the data found in line 18A. We have the pneumatic flow control valve of small film NASA. We have a valve cover. We have pneumatic membrane actuator springs. Propulsion system, pneumatic piston, air-powered hydraulic, motion control technology, MEMS technology group, NASA Jet Propulsion Laboratory, IEEE, MEMS conference, thermodynamics, high temperature, the shuttle, control of liquid propellant flows, SSME, a small portion of liquid oxygen is diverted, electric thruster, upstream pressure bleeds down, cylindrically shaped bore in a piece of metal, motion control technology, over travel, drifting, bearings, low flow ripple, and simple hydraulic controls with no leak adjustments, designed to fit into space is too small for other valves, thin film with silicon substrate MEMS fabrication technology, applications in analytical instruments, mass flow controllers and pressure regulators are at the prototype stage, NASA experimental data analysis of high pressure safety valves, and then these two words, baffle, a device to prevent direct fluid flow or impingement on a surface, and directional control valve, a valve whose primary function is to direct. Just so you know, all these keywords that come up, guess what I did? I Googled them. And they're going to be showing up in the next videos from A to Z. Anything that comes up that's important, I put in and made its own little, it's going to have its own little video, so you can just look at that particular piece of data if you need to, okay? February 2nd, 2012 at 11:17 a.m. Eastern Standard Time. My thoughts. Looking over the data from lines 18A to Z, I can see the words gas, compression, and thermodynamics coming up in each of the lines and with other things. I've divided up each Google search so that we can explore each set of keywords in this section. I believe many of the mathematical equations that come up are ways to determine if these gases are combined, pressurized, and mixed with the neutrino formulas. You would have something powerful enough for a UFO engine, thus giving you the speed you require to travel into the far reaches of the galaxy and the universe in record time. The initial videos are from line 18 to A to Z. Anything that has to be divided up will become A2 to Z2 and so on. So each letter will have a number 2 beside it if I have to divide the data up from that particular line. And then so forth. Like I did that in line 17, I went from A2, A3, A4, A5. You get the idea, right? Believe it or not, I just started with just that photo of that safety valve invention and about 6 links of data. That's what I started with for line 18, and I've expanded it into 26 different possible videos. Then I took the keywords out of the links that look like the ones that have come up before in the Wow Seti lines of data, and that would be from lines 1 to 17. And I did a Google search along with keywords linked to them, and you will be happy to see the data I have found. Again, it's NASA's testing results with other laboratories. By mixing the data together, my puzzle pieces idea, we can create something new, powerful, and useful. Okay? So that's the end of that. I'm going to have to do some more research again for line 18A2, which is going to be the next one. And I'm going to be Googling these words here to find out what they have to do and what we need to do with them. So it'll be mass flow controllers, pressure regulators, prototype stage, the NASA experimental data analysis of high pressure safety valves. I want to see if there's any reports that came up. Then there's the baffle and the directional control valve. Again, if each of these have a lot of data that come up with, it's going to become A2, A3, A4, A5, that kind of thing, okay?